Okay. So, the beautiful thing, what we're about to do today, you've already done. But I've shown you how to write it out the long way. Today I'm going to show you how to write the shortcut. So, permutations. Please understand that permute means to order. Okay? So, we're looking at first, second, third place. We're looking at president, vice president, secretary, treasurer. Okay? One person's more important than the other. Key components. Order matters. Okay? Different places or characters in a password, number, line, or arrangement. Different jobs, duties, or positions. Okay? The president holds something more than what the vice president holds. The vice president's above the secretary. So that is a permutation. Also, objects can never ever be reused or repeated in a permutation. Okay? So, a permutation is an ordered arrangement of objects. Okay? And they note this as NER. So, N represents the total amount of objects that you're ordering. Okay, so I have 20 students. 20 would be your N value. Okay, I need to pick a president, vice president, secretary, and treasurer. So, president, vice president, secretary, and treasurer, how many places am I filling? 4. So, R represents the 4 objects, the 4 places you're trying to do. So, with that being said, that would be 20 P4. Okay. I will show you where the button is on the calculator and everything else. So, what this means, okay, hold up, Trey, because I know where you're going with this, I think. Okay, hold on. Let me get through this page. Okay. So, we've got 20 people. I need a president. How many people do I have to pick from? 20. I now need a vice president. 19.
Since your math, can you count that and tell me if that's 12? Because last time I counted, that's 6.
That's all she gave you total? I didn't even get mine, so.
What is that?
Okay. I now need a secretary. 18. I now need a treasurer.
17.
This is how you would do it when we did it before. This is now the new notation, and your calculator will do all that for you. You don't have to write it out anymore. So 20 times 19 times 18 times 17 means 20 P4. I start with 20 people, and I need the first 4 to fill in my spots. So I start at 20, and I go 4 spots over and multiply all those numbers together. Or you can use this lovely formula. Okay? Most of you will never use this again. The formula. Okay? So, I'm not asking you to memorize the formula. Okay? But it's available to you. Okay, so you're going to see a section on your test where you're going to see 2 permutations and 2 combinations. We're going to do combinations as well. I want the formula or the multiplication statement that you would plug into your calculator. So, if I see 6P2, that means I need to start at 6, and I need to fill in 2 positions. So what comes after 6? 5.
So the other side is just however many spots there is.
Yes. How many spots you're filling. So 6 would be how many people you have and how many spots you're filling with those people. Okay? So 6P4 would be 6,
5, 4, 3.
and 3. Okay? So you always start at that first number and you fill in 4 slots. With that being said, what is 10P1 then?
10.
Or I'm sorry, 100P1, sorry.
100.
100. I start with 100 and I only have one slot to fill. It's only 100. Okay. What about 10P9?
Then it goes
10 million or something?
10 to 8, right?
It's 3 million.
Or 10 to.
That would be.
I'm not looking for the answer. I want the multiplication statement.
Oh,
10
times
9.
10 to the power 9.
It would
No,
be-
it's not 10 to the power of 9.
8,
10
8,
times
7,
9,
6,
6,
8, 6, 5, 2, 2. Right, stop at 2.
The whole way to 2. Good. Okay. The whole way to 2.
When do we use this one?
If order doesn't matter, or if you can't repeat, how are you doing 10 to the power of 9? Allegedly, that's 12. We still can't count because I only 10.
What that is?
She's pissed.
That's great. And she's putting it on YouTube. 4P4 looks like what is a multiplication statement?
4 all the way to 1.
4 all the way to 1. 4 times 3 times 2 times 1. What else could I use here since it goes the whole way down to 1?
4 exclamation mark.
4 factorial. 4P4 is the same thing as 4 factorial. Okay. And 13P5.
11, 10, 9.
Good. Okay. So, again, when you see those, all I want is the multiplication statements. You will not have to answer that section. You just have to give me what you would plug in.
So what's that formula?
We're gonna do it.
1.
It's just that section of the test I want you to show me that you know how to calculate it without the calculator. Okay. So, when we deal with these problems now, you need to ask yourself, can anything be repeated? If it can, it's automatically just a multiplication statement. I have to do this times this times this times this. There's no way around it. Okay? If it's not being repeated, okay, and the order matters, it's a permutation. So start getting those questions in your head. So consider the letters A, B, C, D, E, F, G, and H. So how many options do I have if I have A through H?
8.
8. I have 8 different options. We want to create a 4-letter word out of these 8 options. It says letters can be reused, which means it's a multiplication statement. So that means I can't get away from this for this one. I've got to write this out. Okay. You just told me I have 8 options. So each one of these should be an 8. I can pick anything A through H in each one of those spots. So that's a total of 4,096. So again, your key word here is the fact that it can be reused. You cannot use permutation. Hey, this time, your letters cannot be repeated. If it's a word, the order matters. R is spelled A-R-E, not R-E-A or R-A-E. Okay, so order matters when we're talking about spelling words. So order matters and the letters cannot be repeated, which means I can use a permutation here. So again, how many total options do I have to pick from? 8. How many letters is my word?
4.
This is 8, permutate 4. I don't know why that just went all funky. 8, permutate 4. How many options you have, how many you need. Okay, no repetition, and D is the last letter. Yes, ma'am.
Did you get a hold of Dakota?
I might be able to.
Please to call me.
Okay.
Thanks.
No repetition, and D is the last letter. Okay? So, they've already spelled it out that this one has to be a D.
So that'd be 1, right?
So, if I use that as a D, and I cannot repeat, how many other letters do I have to pick from?
7.
7. How many spots am I trying to fill?
3.
So this one's 7, permutate 3. They specify 1, and the rest you can use as a permutation.
So if on the test, if we wrote it out like A, would that still be right? Like we put 7, 7, 7, then 1.
This wouldn't be 7, 7, 7, and then 1, no.
It would be 7,
This
6,
would be
5.
7,
Well,
then
yeah.
6, then 5.
Because it
Times
can't be
1.
repeated, yeah.
And yeah, that's the same thing. It does the same thing. So if you would prefer that over your permutations, that's absolutely fine. Okay, example 3. 7 candidates are planning to interview for a job, but there's only 4 interview slots. 1 p.m., 2 p.m., 3 p.m., 4 p.m. with the company. How many different interview schedules can the company create?
7.
Why is this a permutation though?
Because you can't have
This is a schedule.
every candidate for every time slot.
Look at your time slots though. I specify exactly what time you need to be there. 1, 2, 3, and 4, which makes it a permutation. When I specify certain things, that changes it to a permutation. So, how many candidates do I have to pick from for the slots?
7.
How many slots do I need to fill?
4.
That's an answer.
Okay, so in your calculator. I always gotta wait on somebody.
Right, y'all need to get y'all calculators when y'all walk in the door.
Tell him to call Miss Byerly. Okay. So you need to type in 7. Then I need you to go to math and scroll over to probability. Is it choice 2 or 3 with the NPR?
2.
2. So choose choice 2. And then hit 4 and hit enter.
40. What does it do?
8, 40.
7.
You would hit 7, hit math, go over to probability, and it's choice 2. And then you would hit 4. So what your calculator just did for you is 7 times 6 times 5 times 4 in one button.
That's cute.
So again, you could have done 7 times 6 times 5 times 4. The same thing.
4.
Okay? Example number 4. A car's new stereo system has a 6-slot CD changer labeled 1 through 6. Jeff has 20 CDs that he regularly listens to. How many ways can Jeff put his CDs into his new car stereo system? How many does he have to choose from?
20.
And how many is he filling?
6. That's a lot of weight. Like,
So how do you know this one's a
27 million knots.
from you?
How do you know that this one's a permutation?
Yeah.
6-slot CD changer. So the fact that they're labeled 1 through 6, so there's certain slots. It's not just going into the mix. It's not a random. Good question.
100,000.
So this should come out to be 27,907,200.
That's it.
Okay, that's it.
That's it, man.
We got number pages.
Okay, a passcode is 8 characters long with no repeated characters, but the first 5 characters have to be lowercase, and the last 3 must be a number. Okay. Again, password. So if I put R before E, I can't write E before R when I go to type it in. So order matters here. Now I'm dealing with two separate things, so I've got to do two different permutations. I need to do one for the lowercase letters. So 26, I've got 26 letters to choose from. How many slots am I filling with a letter?
8.
5.
Oh.
It's 8-character password, but we're splitting. Times. Now I need to talk about the fact that the last 3 have to be a number.
10.
So 10, P, 3. I have 26 letters to choose from. I'm filling 5 spaces with those letters. I then have 10 numbers to choose from, and I'm filling 3 spaces with those numbers. 4 people are running for the position of president, vice president, treasurer, and secretary. How many different ways could these people hold 4 positions? Why is this a permutation?
4 people.
They're running. So yeah.
Is it not 4 people?
It is 4 people, but why is this a permutation?
Because it specifies what they're running
It
for.
specifies what position they're taking. Okay, you've got 4 specific positions that they're taking. So how many people do you have to pick from?
4.
And how many positions are you filling?
4.
So that's 4 exclamation.
So this could be written as 4 exclamation point or 24.
Where's the factorial one?
Probability for.
Math, probability, choice 4. It's right on the same screen where permutation and combination. I don't care either way.
Oh, bro. So if it's like
So,
we can do 4.
I'm okay with you leaving it as 4 permutate 4. Okay.
So we-
But on your final exam, I guarantee you they're not going to let you just leave it like that. You have to actually plug it in.
So like number 5, I would actually have to
I would be okay on your test with you leaving it like that. With your final, they're not going to let it.
Well, the final exam is multiple choice.
Right.
Yeah, but you still need to get to the actual big numbers.
Yeah, but I'm saying like.
Okay. On the first day of class, 30 students find themselves in a classroom with 30 desks already arranged for them, but no seating chart has been made. The teacher gives the students free seating and will write down the seating chart afterwards. How many different seating charts are possible? 30.
30.
Be 30. I've got to put every student in a seat. I've got 30 seats available, 30 students to fill them. Okay? Why is this a permutation?
Because it says 30 students, 30 tests. Right?
That has nothing to do with it being a permutation. I could have 30
Because
seat
once-
30.
No
Because
seat
once they
chart.
sit, he writes down where they're sitting.
Okay? Once Trey sits here, I can't put Sophia on top of Trey. The desk is one person.
Should've used the girl.
Okay? You can't share a seat. Example 8. Consider the set ABC. How many different 3-letter words are we allowed to make without repeating a letter in the word?
3P3.
Repeat 3. I've got 3 letters to pick from, and I want a 3-letter word.
4-letter words.
0.
Okay? So answer me this before we move on to combinations. Why can't a permutation be used to find the results of 3 consecutive flips of a coin or 4 tosses of a dice?
Because the answers are going to repeat.
It can repeat. Okay? Think about it. When you flip a coin, do you then scratch off heads and you only have tails available? No. Every time you've got the same choices. Okay? The same thing with a die. If I throw a die, it also does not change. All right. Well, we're skipping this. Here we go.
That'd be crazy if like you threw a die and then
And it just magically disappeared.
yeah, like it went from a 6-sided one to like a
5-sided.
5-sided. Yeah.
Okay. So the difference between permutations and combinations. Permutation, order matters. Combinations is an unordered selection of objects. Whoops, why am I writing selection when it's already up there? Unordered selection of objects. So, a permutation. If you go to the store and you get an ice cream cone and you want chocolate and vanilla, permutations, it's different if I put chocolate on first and vanilla on second. Okay, that's different than vanilla and then chocolate. Okay, with a combination, both of those are the same. You've got chocolate and vanilla. Doesn't matter what order they're in. It doesn't matter what comes first. Okay, so that is the difference. N still represents how many objects you have. R still represents how many objects you're trying to fill. Order still, or order does not matter, and we still cannot replace or repeat though. Okay, there's still no replacement or repetition. So, with that being said, these should look awfully familiar because you just did them with permutations. The difference is it's 6 times 5 divided by 2 factorial.
What?
Isn't 2 factorial just 2?
Alright, so can you erase that? It was neat.
Oh wait, are you pulling
So-
the 2 from the R from the right? Yeah, okay.
Okay, the 2 comes from here. So what has happened is as a permutation, I count the fact that I've got chocolate and vanilla and chocolate. What it does when I divide by 2 factorial is it takes away all those doubled up options. So B, as a permutation, was 6 times 5 times 4 times 3. Now we divide it by 4 factorial. And again, that 4 comes from there. That is your R value.
So you will use the 4, the spaces that you need and the divisor. Alright.
Factorial.
Okay.
I know that, but. Basis.
So that's just gonna be
So
different.
this one down here, as a permutation was 100, we divide by 1 factorial. So guess what? Still 100. But I'm only choosing one thing. Permutation and combination are exactly the same. Okay. D. This was 10, 9, 8, 7, 6, 5, 4, 3, 2. This time we divide by 9 factorial. Four C4 then was 4, 3, 2, and 1. This time we divide by 4 factorial.
Hold up, so quick question. B be 10?
Yeah.
This
So
is
those-
1.
Oh, is it always?
Because what is 4, 3, 2, and 1? That's 4 factorial. The same thing divided by the same thing is always 1. What Marcus has just decided, 9 factorial. We know, don't change yours. We know 9 factorial is 9, 8, 7, 6, 5, 4, 3, 2, 1, correct?
Yeah.
Watch what happens. They cancel out. So all you're left with is 10 divided by 1, which makes your actual answer 10.
Under there.
Mind blown.
That's
Mind
blown.
Mind blown. 13C5 as a permutation was 13 times 12 times 11 times 10 times 9. And this time we divide by 5 factorial. So you always divide by the amount of numbers that you multiply together.
Alright, well, it's gonna be.
Question.
Stop with it.
got a test on Monday.
Oh,
We finished on this today.
well, the whole package?
Yes,
What,
we're almost there.
I see that one page.
Do not have 8 more pages.
we got 3, front and back.
These are literally just nothing but a bunch of examples.
Really?
You fine.
What, after
Three.
this?
Okay,
All examples?
so
Except for
what
this.
you need to do is you need to decide which is a multiplication rule, which is a permutation, which is a combination. Okay, if it does not say you cannot repeat, repetition is allowed, which means multiplication rule. If the order matters, it's a permutation. If the order does not, it's a combination. So if I asked you, how many 2-digit numbers can be made from 1, 2, 3, and 4? Which one of these 3 would you pick? Is that your multiplication rule, permutation, or combination?
Permutation.
Yeah,
All three.
because it gives you 4 specific numbers. So it's permutation.
It does, but does it tell you you cannot repeat a number?
No.
No,
So it's the combination.
it's multiplication rule.
Multiplication, right?
If you can repeat, it is multiplication.
I'm gonna write that down somewhere.
Okay?
You said what?
If you can repeat, it is multiplication.
You can do it like-
Okay, right.
So what would it be, 4 times 4?
So it's 4 times 4. I've got 2 slots to fill, and in each slot, I've got 4 numbers to pick from. So it's 4 times 4, or 16. It will tell you cannot repeat, okay? Or 2 different. And that tells you that it cannot be repeated. So the second one, how many ways can we select any group of 2 different numbers from 1, 2, 3, and 4? It says different numbers. So that tells you no repetition.
No, it's,
That's permutation.
yeah. No, it ain't, because order don't matter.
Order doesn't matter here. It says select any group.
So combination.
Does not matter. So this is a combination.
So you can do 34 and 43.
Okay. How many numbers do I have to choose from?
4.
4,
4.
And how many spots am I filling?
2.
2. I'm sure.
2, it's a 2-digit number. So that would be 4C2. Remember, I can also write this up here, this multiplication statement, as 4 to the 2nd power. So 4 to the 2nd, 4 and 2,
4 to the 2nd.
okay? It's all the same numbers, it's just how you put it.
P4, 4P2.
So how many ways can 2 different numbers be picked in order?
6.
That's what makes this a permutation now. So I still have 4 numbers to choose from, and I still want a 2-digit number. So this one's 4P2,
So we can remove all of them.
okay? So your key here is the fact that it's different, so that tells you no repetition. This one says in order, so it's a permutation. And this says select any group, so it is a combination. Question. Okay, let's take a look at this one. To win the jackpot in the lottery, you must select 6 numbers from 1 to 53. How many possible lottery combinations are there? One of these is a multiplication roll, one is a combination, one is a permutation. You need to figure out which.
That is more.
Take a minute, look at it, write down what you think, and then we'll go over it. Give everybody a chance to
We're
look
just
at
writing
it
down
and
what
see
we
what they
think
can
the
do.
rule is.
Huh?
We're just writing down what the.
Yeah, whether it's a multiplication, a combination, or a permutation.
Got it.
I think you got it?
Yeah, I do that.
You do got it?
Yeah.
You go, boy.
I'm gonna let them. No, I make 100 on my test. If I make 100 on this test, give me 100 homework grade. One of them zeros. I mean, right. It's a test.
Okay, take a look at the top one. You can select the same number as many times as you want, and the order matters. Multiplication roll. Same number. So how many numbers do I have to pick from?
54.
53.
Oh, 33.
53 numbers.
You ain't got 0.
How many spots am I filling in with this 53?
6.
6. So 53 to the 6th power. Okay. Or you could have written out 53 times 53 times 53. Okay.
I got a lot.
Order matters right there.
If you cannot select the same number and you win with having the numbers in any order, this is a combination.
Right. 'Cause it don't matter.
What number goes out front?
53.
And 6. Did you notice the bigger numbers always have to be to the left, smaller numbers to the right? Okay, don't ever reverse it because when you go to plug it in the calculator, it's going to tell you,
Unless it's 4.
can't do it. Okay, the last one, you cannot select the same number and you only win with having the numbers in the same order as what is drawn.
53P6.
53P6.
I think you might as well go ahead and give me.
Go ahead and give you 100.
Yeah, I ain't even got to take the test. To be honest.
Awesome.
Still.
7 possible meeting times, and a committee must meet 3 times. The number of ways to assign the meeting times is multiplication, combination, permutation.
Nope. Because 7 possible meeting times.
And must meet 3 times.
Right. So you got 7 times
It's a combination.
for 3 times.
Why is this a combination?
Because it don't matter what time.
It doesn't matter what time. Okay? This is not a multiplication rule because if I go to a meeting time, I'm not going to go to the second meeting and the third meeting.
Oh, yeah.
Okay? That's why it's not the multiplication rule. Example 5. A number of 5-member delegations that can be created from a 9-person group. How many delegations can be selected?
Is this permutation?
No.
Does the order matter?
Yes. 5 members.
Okay, so first question you should ask, can it be repeated?
That's
Yeah.
what I'm saying. I don't think it can. You
Yes,
can't
it
have the
can.
same
Because it doesn't say.
Why
Number.
can't, I'm talking about what?
groups.
5.
People.
Yeah.
Right.
You
Right.
can't.
I'm talking about people.
You ain't got 2 meetings.
Yes, there's twins and triplets, but they're still not the same. Okay, they're 2 different people. So anytime you're talking about people, it can't be repeated. Okay, you can't make a clone of me. It doesn't happen. So we're either permutation or combination.
Permutation.
Does order matter with how many delegations can be selected?
Actually,
Now,
No, which means this is a
combination.
combination.
you got 5. Oh, you got 9 and 5.
9 and 5. Okay, take a look at the difference between A and B. B says how many delegations can be selected if the members are assigned as a speaker, recorder, researcher, facilitator, and administrator.
That is
That's a
P.
Now, this is the permutation. We've gotten specific. They have specific jobs. I have a speaker and a recorder and a researcher and a facilitator and an administrator. So that changes it to permutation. In the first one, they were just being thrown on a committee. Okay, that's like being on student council. Okay, everybody's the same on student council except for the president of student council, the vice president of student council. Okay, everybody in the House of Representatives are the same. So that would be a combination. Take a look at 6. 20 students put their names into a hat to win one of 3 gift cards. How many different ways can students win gift cards if they're getting $20 gift cards from Starbucks?
This multiplication.
It ain't.
Again, how is it multiplication when I'm dealing with people?
It's not.
Oh.
It's what you call it.
Combination.
Yeah.
This is a combination.
Because you put the name back in there, they can pull it back out again. You know what I'm saying? You got 20 and 3 right there.
So 20 and 3. B, how many different ways can students win the gift cards if they choose 20 from Starbucks, Dunkin' Donuts, or Krispy Kreme?
See, that's that P right there.
This one is the P. everybody was getting the same thing in A. Everybody's getting the same amount, but for a different place in B. So that's what changes this to a permutation instead of a combination.
$20 donuts by 3 o'clock. We'll go down to the opposite. We're gonna have a problem with somebody.
You wanna fight them?
Yes.
What if they just don't even come? That'd be messed up.
12 players are on the varsity basketball team. We are asked to determine how many possible starting lineups the head coach could use. How many different lineups include a point guard, shooting guard, small forward, power forward, and a center?
That's that P right there.
Yeah.
That's permutation.
12 and 5.
12 and 5.
Okay.
I have 5 positions: point guard, shooting guard, small forward, power forward, and a center.
Let's see right now.
Yeah, the next one. And then the next one's C.
The next one's C. Any 5 players. They're not giving a specific job. Okay. So here's where we start to change it up a little bit. Okay. How many different lineups include 2 guards, 2 forwards, and a center?
So would that be, that's the P right there.
It says hint. This is different and requires a use of multiple combinations.
So you can do.
Whoa!
Is it 12? Is it P something P? I know that.
No, whoa.
Hey, you better shut up, boy.
Let's just chill. Just chill.
It says multiple combinations.
Yeah, but you
Yeah,
get
so
a
there's
Okay,
gonna be 2
so
C's.
we're talking about guards,
Oh, yeah,
but we're not
that's
talking about a point guard and a shooting guard. We're just talking guards. So we take it one piece at a time. We've got 2 guards. How many people do I have to pick from? 12. And I want 2 guards. So how many people am I picking? 2. Okay, we've done that. And I now need 2 forwards.
10.
Why is it 10?
You can't use the other 2 people.
I've taken 2 out. Okay, so 12 minus 2 gives me 10. So now I only have 10 people to pick from, and I need 2 forwards. So 10C2.
8
Got
times
that.
8 C1.
And now we're down to 8 people, and I want 1 of them.
All right.
Okay? So it's the same, but it's different. Questions?
No.
Okay. 4-digit numbers. Okay. So I need 4 digits. 1, 2, 3, 4.
Oh, I did good.
Here's your specific again. Just like the 2 guards, the 2 forwards, and a center. I need 1 5. So one of these spaces has to be filled with a 5. Okay, so I write that as I have 4 spaces available and I'm filling 1 of them. 4C1. That takes care of this 5. Okay, that takes care of that 5. Okay, all of my other digits can be reused. So I can reuse any one of my numbers except my 5. So how many options do I have here?
10,000. Or is it 99,000? Oh,
99,
yeah.
9,998. Or 90.
No. That's a 4-digit number. Each slot can be filled with 1 digit.
So 10.
So I had 10 to begin with,
So,
and I take away the 5,
So no.
so I've got 9.
And we all know.
Right, big time.
8.
Okay, it says these ones can be repeated, which means I have how many options here? And how many options here? So this is times 9 to the 3rd.
So can you explain, like the combination, how that makes 5?
Because I have 4 slots for my 4-digit number, and I'm filling 1 of them. It doesn't matter that it's a 5, I'm only filling 1 of them.
Okay.
So that's where the 1 comes from, okay? What?
Why can't we tell? Because don't you put the flag up?
No, it says all other digits can be repeated. So that means everything but the 5, okay? They will throw in any word they can to confuse the crap out of you.
They don't care about us.
They don't
I
wanna see
do.
us succeed.
That's why next Tuesday.
They don't
Okay.
wanna see us succeed.
So this time, I have still a 4-digit number. One of them needs to be a 7. Okay, so I have 4 slots and I'm filling one of them.
987.
Okay, so I've used the 7. No other digits can be repeated. I've used the 7. So how many digits do I have here to use? 9, 8, and 7. So this is times 9 times 8 times 7. Are we good on these two? You see where this comes from? If not, I need you to stop me now before we get even deeper into this. And then you're looking at me at the end going,
Okay, so what would that, I thought you could use 7.
That's not the
It's
number.
okay.
Number 7.
That's how many choices.
Oh,
you
that, okay.
Yeah.
All right.
We good?
Yeah.
Yeah. This is the number that they used. Actually. So instead of doing that, we need to remove one of these. So instead of writing the number there, let's just erase it. So I have an empty spot that I fill with a number. And then I only have 9 options, 8 options, 7 options. Okay. All right. Take a look at C. This time I'm filling 2 of the slots. Okay, so I've got 2 slots left. So how many total slots did I have to fill?
4.
And I'm filling 2. So that's 4C2. That takes care of the fact that we're filling 2 slots with 9s.
So you got
All other digits can be reused.
9.
9 times 9. I've used 9s, so I don't have any 9s to use. I have 9 other digits. So 9 times 9, or you could write that as 9 squared. And finally, D, how many of these numbers contain 2 8s? So 2 of my slots have to be filled with 8s. If I pull out an 8,
Not 8.
I have 9 left, and then I can't repeat, so then I only have 8 left.
They're really bugging with these donuts, though.
Right.
I don't even want mine, but since we're supposed to get them, I'm hungry now.
Maybe she
Yeah,
went and
for
got
real.
them fresh.
And then I saw them in every Krispy Kreme in the time frame to do that.
Okay. A necklace of 10 beads can be made from blue, gold, and white beads. How many necklaces have exactly 3 blue beads? Okay, this is just like the ones that we just did with the spaces. So here, I've got 10 beads. I need 3 of them to be exact. So I have 10 beads, and I want 3 of them to be blue.
So then, can't use 3 no more, right?
Okay, I now need to fill how many other beads? How many more beads do I need to add to my necklace?
7.
7 more beads. How many options do I have for those 7 beads?
4, 3,
You got 2.
blue, gold,
You have-
and white. That's
You
3.
can't use blue no more.
But it says exactly 3 blue, so I can't use blue anymore. So I have 2 options left. And I need to fill 7 beads with those 2 options. Do the 7.
I just, the combination thing, I don't understand, because it's giving you an exact thing that you can
Right.
use, so it's not like.
But
I-
is it telling me that it needs to go blue here, and blue here. With what in between. It's not telling you exactly where it needs to go. It's telling you exactly how many.
Okay.
So I can have blue, 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 and then white, gold, white, gold, white, gold, or I could have blue, white, gold, blue, white, gold. It's not telling you the exact position. Does that make sense?
Yeah, that makes sense.
Okay. How many necklaces have exactly 5 gold beads? How do I-
5C3.
5C3?
Oh, I'm tripping. 5. No. I mean,
Is it?
no, it's 10C5.
10C5. I've got 10 beads. C5. Okay. I've put my gold beads on. How many other options do I have?
2.
2.
Oh,
How many beads do I need to add to my necklace still?
5.
5. So 2 raised to the 5th. Okay. How many necklaces have exactly 3 blue, 2 gold, 5 white? So again, piece by piece, I want 3 blue.
10C3.
10C3. I have 10, and 3 of them are going to be blue.
Times.
7C2.
Okay. I've taken 3 of my beads and used them, so I only have 7 left. See, 2 of them need to be gold.
Right.
Times, how many beads do I have left to fill?
2.
I've filled 3
5.
and 2. I have 5.
I did it backwards.
See?
4. Oh, 5.
5. It's asking for 5 white beads.
So you can just put 5.
Okay.
I'm on D.
Oh, that's why you're getting confused. Okay, so up here we had to tag on times 2 to the whatever, times 2 to the whatever. Here, I don't have to. When you do it, when you have to piece them together, and this last one comes out to be 5C5, where it's the same number and the same number, you know you're done. You filled in all of your beads. We filled in 3 plus 2 plus 5, which gave me 10. Okay. Finally, the last one then, Trey.
Of the day.
Let's see what we can do. How many necklaces have exactly 4? Write exactly 4 for me, Trey.
Exactly 4.
Yep.
Yeah, right. Exactly.
What does that look like as a combination?
I literally wrote
10,
C
C,
4.
4. How many beads do I need? And I'm going to put 4 of them. How many beads do I need now after 4?
6.
6. How many are exact again?
4.
4.
Do you got how many left?
How many are left?
2.
2. And I'm going to use 2.
So you done, because you got 2
So
too.
you're done. It's 2C2.
You said that was it for today, then.
No, Saphir, you have a test
We heard that.
on Monday
Yeah.
for the 18th time.
Fine.
You need to say my name like that on
Michaela is making a bracelet that has red, green, and blue beads. Each bracelet will have 5. So, how many have exactly 2 green and 3 red?
So 5. C. 2.
Okay, I've used 2 of my beads. How many are left?
3.
3.
C. 3.
Fantastic. How many bracelets have exactly 2?
5C.
Okay, we have a problem. We've only filled in 2 beads. I need a total of 5. I have no more exact. So, how many color options do I have once I've used my green?
2.
2. Once you use green, all you have is red and blue. So there's 2 options.
To the 3rd, right?
And I have 3 beads left to fill, so it's 2 to the 3rd. How many different bracelets have 3 red, 1 green, 1 blue?
3.
5C3,
4 C1.
4.
2C1.
2C1, and 1C1. Okay, remember, I have 5 total. I've used 3, so I have 2 left to fill.
Right.
Okay. How many different bracelets have 2 red, 1 green, 2 blue? 5C2.
Three,
We've got 3 left. C1. 2 left. C2. Last ones, easiest ones yet. How many different bracelets are possible to make? Well, how many options do I have?
three.
3 colors and 5 beads. 3 to the 5th.
So, like, so you see how it's like 5 and then 3 times 2, so and then that equals 5, right? And then 1 times 1 right there. Like, I don't really know how to explain it, but it equals that number like before the C, like the 2 numbers. in the
So
middle.
yes, I started with 5. I'm using 3 of them, so I only have 2 left.
Yeah.
I have 2. I'm using 1 of them, so I only have 1 left.
Okay.
Yes, that's exactly what's happening here. I started with 5. I'm using 2 of them, so I have 3 left. I have 3. I'm using 1 of them, so I have 2 left. I have 2. I'm using 2 of them, so I have none left, so I'm done.
Yeah, I'll just go to that second.
Okay. That's exactly how that works. These numbers. Okay. Take a look at this one. A rally is to be chosen from a set of 7 different make foreign cars and 4 different domestic cars. How many ways are there to form the rally if the rally has 5 total cars? We need 3 foreign and 2 domestic. How do I write that I need 3 foreign cars?
5C3.
What? 7. Take a look. It says I have 7 domestic. Or foreign, sorry. So I have 7 foreign cars and I want 3 of them. Don't worry about the fact that this says 5 cars total. That just means 3 and 2. Give me 5. I need to break it down. I need to pick 3 from the foreign. I need to pick 2 from the domestic. So we pick 3 foreign and we need 2 from the domestic category. 4C2, good one. Juan's on his A game over there. He's like, I got this. Is it kind of clicking?
We should call the office and ask them where our donuts are.
The rally has 9 total cars, in which 5 are foreign and 4 are domestic.
Really?
So, how do I write I need 5 foreign?
7C5.
7C5. And I need 4 domestic.
4.
Okay, I can only pick cars from the slots that they belong to. I can't pick foreign cars out of domestic cars. So that's why the 7 goes with the 5 and the 4 goes with the 4. Okay, I need 4 foreign and 3 domestic.
7C4
7C4
times 4C3.
and 4C3. Okay. Think about what this means before we start writing this out mathematically. The rally can be any size except empty. I can't have a rally with no cars at all. But it must have an equal number of foreign and domestic cars. So if I have to have an equal number of foreign and domestic, I can have what? 1 and 1. Okay,
Yeah.
so I write that as 7C1 and 4C1. What else can I have?
7C4. 4C.
Okay,
That's a
I can have 4 of each. What else can I have?
7C3.
I can have 3 of each. 7C3 and 4C3.
You can
and I can do 2. Oops, that needs to be a 4. D2. Can I have 5 and 5?
No,
Why?
there's
Because there's
no
only
five.
4.
There's only 4 domestic cars. Good. But you have to take into consideration that I can have 1 and 1, 2 and 2, 3 and 3, and 4 and 4.
Did I ask that question?
Listen, I could make it even more torturous and have you plug that in and give me a final answer.
Oh, no.
I got you.
Right. Yes. Okay. All right. Yes. Combination, the NCR, yes. Okay, we're gonna skip this example for right now and talk about subsets real fast.
All night.
I don't think we're getting donuts.
They're
today.
watching the live stream. They know that.
Subsets contain at most all of the elements or at least none. So now I'm going to throw in words at most and at least. Okay, so you need to understand what those mean. And we will talk about them as we do that. So this means, and just like we kind of talked about with the foreign and domestic cars, I can have a set with absolutely nothing in it. I can have a set with just element A. I can have a set with B. I can have a set with C. I can have A and B together, A and C together, B and C together, or all 3 of them at once. This should take you back to, what was it, chapter 2 when we did weighting voting systems? And you had to do the Bons-Hoff power index.
Yeah, I don't remember.
Okay, we're not going to completely do that, but that's kind of what this is like. Okay, in general, the number of subsets of an element set is 2 to the n. Okay, so if I'm talking about everything in the subset, the empty set, clear up to everything in the set, I can write that as 2 to the n, where n is how many objects we have. Okay, so that is always a shortcut. Or you can write it out. I want none, plus I want 1, plus I want 2, plus I want 3, plus I want 4. Well, when you have 16 things, you're not going to want to write that out. You're going to want to shorthand it. Okay, so let's take a look at some of these. In a pizza parlor, there are 8 different toppings to add to a cheese pizza. Okay, we've got 8 toppings. How many different pizzas can the parlor make? So that means I can put no toppings on it, 1 topping on it, 2 toppings on it, 3 toppings on it, the whole way up to 8 toppings on it. So that's your empty set to the whole set. So instead of writing that out as a big long 8C0 plus 8C1 plus 8C2, we can simply say each topping, I have 2 options. I can say, yes, I want it. No, I don't. How many times am I going to say yes or no?
9 or 8.
8.
8.
So that answer is 2 to the 8.
My question is, how are they gonna have an incentive program?
It doesn't say it's an incentive
No, I'm talking
program.
about their donuts.
I knew you was talking about that
gosh.
shit.
Okay. Can we finish getting through this and then you guys can learn about it? Exactly. So is mine. My lunch is sitting right there.
Can I have some?
Because it didn't get here until beginning of 4.
Can I have some?
Exactly how many different 3-topping pizzas could you make? Okay? Exactly.
So that's P, right?
No.
Or still C?
Does it matter if I
Yeah,
put
that's fine.
pepperoni on your pizza before I put mushrooms?
No.
No, it doesn't. This is combination.
Would it be 8 and 3?
8 and 3. We're only caring about the 3-topping pizzas. We don't care about anything else.
True.
Okay? Take a look at the difference between B and C. So now I still want a 3-topping pizza, but now I get to pick from 3 crusts and 4 sizes.
Combination.
So it's still a combination for your toppings, 8C3. But then I need to multiply this by the different crusts I have.
3 raised to 4.
And I also need to multiply this by how many sizes I have. Take a look at D. The number of pizzas with at most 3 toppings. What does at most 3 mean? Nothing above 3. So what does that look like? I can have 3 or 2 or none. Okay? So I need to take into consideration each one of those scenarios. How do I say exactly 3 toppings?
3C3. Oh, 3.
3 or 8C3.
8C3.
Yeah.
Or tells me to do what?
Put.
Add. How do I write? I want exactly 2 toppings. 8C2. Or 8C1 or 8C0. So at most means I can have 3, 2, 1, or 0. So I need to do each one of those individual scenarios and add them all together.
If we left out 8C0, we still get the same answer.
No. The number of pizzas with at least 3 toppings.
So 8C.
So that means you can have 8C8.
That means I can have 8C3, that's 3 toppings. What else can I have?
8C4.
8C4, 8C5,
6, 7, 8.
6, 7, and 8. Okay. We only have one more example of this, and then we'll go back and do that one that I skipped. Unless you don't want to do the one I skipped.
Donuts will be done.
It's gonna be
I
done.
have to call Kansas.
One my donut, but
Okay.
they be lying.
A pizza parlor offers 6 different toppings: pepperoni, sausage, mushroom, olives, peppers, and onions that can be put on a basic cheese pizza. Customers can also choose deep dish, original, or thin crust. Okay, so first off, we need to be concerned with the toppings. How many ways can you make a 3-topping pizza in this scenario?
2 to the 6? No.
No. I'm making a 3-topping
3 to the
pizza.
6?
3
No.
toppings.
Man.
A pizza parlor, 6 different toppings.
63.
Okay.
I've got 6 different toppings, and I want 3 of them on my pizza.
You got 6 options for
63. Okay. But we need to take into consideration too, not only do I have to worry about the toppings, I have to worry about the fact that I have 3 crusts to pick from. So once you get that, you multiply it by 3. Okay. You have to multiply it by the crusts as well.
I like thin crust.
Okay, now, how many different pizzas can be made in all? So that's nothing on your pizza up to every topping on your pizza. So my shortcut was 2, because you get to say yes or no
2 to the 6.
to the 6 power, because I'm saying yes or no to the 6 different toppings, and I still have to multiply that by 3. How many pizzas have at least 4 toppings?
6.
6.
4.
3.
4.
4.
Options for 4 spots.
Plus
3.
5.
Oh, 6.
65.
6C.
Oh, at least.
6.
All of it.
Your words were at least, which means 4 or more. So I can have 4 toppings, or 5 toppings, or 6 toppings times 3.
Goodness gracious.
Hey, these egg rolls back here smelling good. That's why you need
Are they?
to come get these off my way.
Okay. At most 2 toppings. At most 2 toppings.
So that means you can have 2 or 1. 6,
So
6C2, 6C1, and then you got 6C0.
Good, 6C0
Times 3.
times 3. How many pizzas can be made with exactly 2 or 5?
So you gotta add right there.
So 6,
6C2,
6C2,
6C1, oh, wait,
Plus?
6C5.
6C5. Good. I don't care about anything in between. It says exactly 2
Right,
or 5
times 3.
times 3.
Hey, we on the road today.
You on a roll and you ain't butter.
I think you should just give us like 5 points on the test already.
I could have used a donut.
I said,
To be honest.
"Y'all."
So we